Hey class, today we're going to talk about theorems about roots of polynomial equations, which is found in section 5-5, part 1 of your book. We're going to solve equations using the rational root theorem. I know this is kind of blurry, but basically what this says is if you have a polynomial, you can find the possible rational roots by putting p over q. Now, let me go ahead and tell you what p is. P is the coefficient of your constant. Well, and I really shouldn't even call it a coefficient. So this number at the end, for example, is 10. Okay. And then q is the coefficient of your leading term. So p over q would be 10 over 21. So in other words, you would have to find all the factors of 10, all the factors of 21, and then make fractions out of them. And those are your possible roots. So let's look at our next example to kind of get a better understanding of that. All right, so in our first example, you want to be sure that everything's in standard form. We've double checked. Everything is in standard form. It goes from third power down to no power. So that's accurate. And then after that, you want to identify your p and your q. So p is 5 and q is 2. So what we want to do is list the factors of p and q. So the factors of 5 are 1 and 5. Okay? And then the factors of 2 are 1 and 2. So when we begin to list our possible roots, that would be p over q. And be sure that you understand that it's plus or minus, well, I'll say this. All the factors are plus or minus. So when I write all of my possibilities, that would be, if I start with 1 and I put them over all the q's, that could be plus or minus 1 over 1, plus or minus 1 over 2. Okay? From there, I'm going to test the second part of p, which is 5. So that'd be plus or minus 5 over 1, and then plus or minus 5 over 2. And then in the end, we should just reduce. So really what that comes down is to plus or minus 1, plus or minus 1/2, plus or minus 5, and then plus or minus 5/2. And we are done. So those are the possible roots of that polynomial function. All right. In try 1, we're going to do the same thing. So again, you want to identify your p and your q. 8 is p, 3 is q. Okay, so the factors of -8, and be sure that you list them like how we did the factors of AC, right? So the factors of 8 are 1 and 8, right? And then we also have 2 and 4. Okay, and then the factors of 1 and 3 are just 1 and 3. Okay, and don't forget that everything is plus or minus. So I'm just going to say plus or minus and then kind of distribute that throughout. So my possible roots, and I have a lot on number 1, try 1. So those possible roots would be, remember it's p over q, so that would be plus or minus 1 over 1, plus or minus 1 over 3, plus or minus 2 over 1, plus or minus 2 over 3, plus or minus 4 over 1, plus or minus 4 over 3, plus or minus 8 over 1, and then plus or minus 8 over 3. So as we finish that one out, if you simplify, right, because if something needs to be simplified, go ahead and do that. That means that your possible roots are plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus 4, plus or minus 4/3, plus or minus 8, and then plus or minus 8/3. And we are done. All right, now on example 2, we take it one step further. instead of just finding what the possible roots are, we actually figure out what the roots are, okay? And so we start by finding the possibilities, and then we start testing points, okay? So let's check and see what that does, okay? So first of all, remember you still got to do P and Q. So this is P, this is Q. So the factors of 2 are 1 and 2, and the factors of 15 are 1 and 15, and 3 and 5. All right, so our possible roots are plus or minus 1 over 1, plus or minus 1 over 3. I'm putting these in order. Plus or minus 1 over 5, plus or minus 1 over 15. Keep going. Plus or minus 2 over 1, plus or minus 2 over 3, plus or minus 2 over 5, and then plus or minus 2 over 15. All right, so moving past this, we then try to figure out by testing certain values what our final answer should be. And here's the deal. Now, the whole reason why we even try to even deal with what are the possible values is because there could be so many different values, right, of rational or rational roots of a polynomial, but it's better to be able to kind of narrow those choices down by being able to figure out the possible roots. And then after dealing with the possible roots, then we test those roots. So we're going to call this test 1. And in test 1, we are going to test positive 1 as our x. So basically x, let me go ahead and do that again. Basically, we're going to test x as 1, all right? So let's see. If I substitute that into my equation, I'm going to have 15 times 1 cubed minus 32 times 1 squared plus 3 times 1 plus 2, and I want it to equal 0. Okay? What ends up happening is I get 15 minus 32 plus 3 plus 2. Again, I'm still hoping that it equals 0. But in this case, actually, it does not. Because, let me check with my calculator. 15 minus 32 plus 3 plus 2 actually gives you negative 12, and that does not equal 0. So x equals 1 is not a rational root. Okay, so we're going to test another one. So this is now test number 2. That should have been number 1. This is test number 2. So this time, instead of testing positive 1, we can test, let me see. I want to do positive 1 or do I want to do negative 1? It's really your choice. You could test negative 1, or you could just move on to the next whole number. So just so we can kind of get in the swing of things, I would test the negative version. So that would be x equals negative 1. So here we go. 15 times negative 1 cubed minus 32 times negative 1 squared plus 3 times negative 1 plus 2, and we're hoping that it equals 0. Okay, negative 1 cubed is going to be negative 1, so that's going to give you negative 15. Negative 1 squared is 1, so that's negative 32. Minus 3 plus 2. I can tell based on the amount of negatives that is also not going to equal 0. So plus or minus 1 does not work. So we're going to do one more test before we have to start dealing with fractions, okay? And so we're going to do a third test, and we are going to test x equals 2. So here we go. 15 times 2 cubed, minus 32 times 2 squared plus 3 times 2 plus 2 equals 0. Okay, so what that is going to give you is basically 15 times 8, that's an 8, minus 32 times 4, plus 6 plus 2 equals 0. Well, let's keep checking. 15 times 8 is 120, minus 128, plus 6 plus 2 equals 0. That one actually works. So x equals 2 is a value. Now here's the deal. Once we have that, right? We want to then go and check to see what the other factors are. Okay, so now that I know that x equals 2 is a factor, I want to use that and divide 15x cubed minus 32x squared plus 3x plus 2 by x equals 2. And we're going to do that process through synthetic division. Okay, and realizing and understanding that our answers still have to come from the possible roots. So I'm going to erase some of this. I'm just going to erase the first and second test, because we don't need those anymore. All right, so if we keep going, all right, x equals 2. Remember, if I start using synthetic division, that's really 2 on the outside, right? And then I need to put them, my values, I use the coefficients of my polynomial. So that's going to be 15, negative 32, 3, and 2, because it's already in standard form, so that works just fine. So if I bring down 15, we begin. So 2 times 15 is 30. Negative 32 plus 30 is negative 2. 2 times negative 2 is negative 4. If I add those, I get negative 1. 2 times negative 1 is negative 2. 2 minus 2 is 0. So this once again proves that 2 is a root, right? Because if our remainder is 0, it is a root. But from there, we should write our equation. So our new equation is going to be, remember, you use one power lower than your highest. So it's going to be 15x squared minus 2x minus 1 equal to 0. Okay? From there, it's quadratic. And we know how to factor quadratic functions, right? I can use AC to help me determine my other factors. So AC is going to be negative 15. And the factors of negative 15 that give me negative 2 are going to be positive 3 and negative 5. All right, so if I substitute, that's 15x squared plus 3x minus 5x minus 1 equal to 0. Okay, group and group. The greatest common factor here is 3x, and I'm left with 5x plus 1. If I take out negative 5, I'm still left with, nope, can't take out negative 5. Let me redo that. I can take out negative 1. Sorry. So if I take out negative 1, I'm left with 5x plus 1 equal to 0. So my factors, in addition to x equaling 2, the factors are, which by the way, if that's x equals 2, then really that is x minus 2, right? Okay, but the factors are going to be 3x minus 1 and 5x plus 1 set equal to 0. So if I set each one of those individually equal to 0, then I can find what my other two roots are. So let's not forget, my first root is x equals 2, okay? And we're going to find the other two. So for this one, if I set that equal to 0, I would add 1 and divide by 3. So x would equal, if I add 1 and divide by 3, I get 1/3. And look, it was right here as a possibility. So x equals 1/3 is one of the other roots. And then the next one, if I set that one equal to 0, 5x plus 1 equal to 0, I would subtract 1 and divide by 5. So I would get x equals negative 1/5. And again, it was right here. So these are my possible solutions for this polynomial. Okay, and actually they're not my possible ones, they are my rational roots of that polynomial. Okay, let's try this process again one more time just to be sure we've got it. Okay, so again on try 2, we start with p over q. So p is 6, q is 2. So p, oops, the factors of 6 are 1 and 6, and then 2 and 3. Factors of q are 1 and 2. So the possible factors are plus or minus, and I'm just going to make a list. That's 1 over 1, 1 over 2. 2 over 1, 2 over 2. 3 over 1, 3 over 2. And 6 over 1, 6 over 2. Now, what I'm going to do is clean these up a little bit because we know that 1 over 1 is really 1. We know that 2 over 1 is really 2. We know that 2 over 2 is really 1, so there's no need in duplicating, so I'm going to get rid of it. 3 over 1 is really 3. We'll keep 3 over 2. 6 over 1 is really 6. And 6 over 2 is really 3, so we're going to get rid of that one also. Oh, that's weird. It doesn't want to erase. So we're just going to, we'll just cross it out. All right, so moving on from there. Excuse me. So remember, we need to test. So I like to test the whole numbers first, the positive and negative versions of those. So here we go. If I test x equals 1, okay, I would have 2 times 1 cubed plus 1 squared minus 7 times 1 minus 6 equal to 0. 1 cubed is 1, so 2 times 1 is 2, plus 1 minus 7 minus 6. That's really 2 plus 1 is 3. 3 minus 7 is negative 4. That's not going to equal 0, so x equals 1 is not going to work. If I do x equals negative 1, let's see what we get here. We would have 2 times negative 1 cubed plus negative 1 squared minus 7 times negative 1 minus 6, hopefully equaling to 0. So negative 1 cubed is negative 1, so really that becomes negative 2 plus 1 plus 7 minus 6 equals 0. Negative 2 and positive 1 is negative 1 plus 7 is 6. Minus 6 does equal 0, so x equals negative 1 is a factor. So now that we know that it's a factor, we're going to use synthetic division. So I'm going to erase this information. I'm going to erase our test. Now we're going to use synthetic division to find the other factors. All right, so if x equals negative 1, we need to use the coefficients of our polynomial. So that's, and it's already in standard form, so 2, 1, negative 7, and negative 6. We're going to bring down 2. So negative 1 and 2 is negative 2. This gives you negative 1. Negative 1 and negative 1 is 1. That gives you negative 6. Negative 1 and negative 6 gives you 6. It gives you 0. That's what we wanted because we want it to be a remainder of 0 to prove that it is a root. So the equation or our polynomial function that's left over should be 2x squared minus x minus 6. And we need to set that equal to 0. Okay, AC is going to give us negative 12. The factors of negative 12 that are going to give us negative 1, we know it should be 3 and 4, but specifically it's going to be positive 3 and negative 4. So here we go. I'm going to replace positive 3 and negative 4 with that negative x that was in the center. So here we go. 2x squared plus 3x minus 4x minus 6 equal to 0. Group and group. Greatest common factor here is x, and I'm left with 2x plus 3. Greatest common factor of the second part is negative 2, and that still gives you 2x plus 3. So the factors are going to be here, x minus 2 and 2x plus 3. If I set those equal to 0, my other factors will be positive 2. And for the second one, if I subtract 3 and divide by 2, that's going to be negative 3 halves. So my rational roots for this problem are x equals negative 1, 2, and negative 3 halves. And we are done. Guys, if you have any questions about this, please come see me for tutoring so that we can go over this and clear up your questions.